All right. Hi, everyone. Welcome to my video, Maths Made Easier with Terry in 10 minutes. Okay. In the previous video, I laid some protocols and I also talked about the 5 rules on how to solve our addition formula. Before you come here to watch this video, you have to watch the previous video. And what you have to do is that you need to know the 5 steps, okay? And get used to it. So I told you that the first thing you have to equate both equations, and I listed everything down there. All right, so we're going to jump straight into this. Now, let's assume we have a question like this, that you're told to convert 5 cos x minus 3 sin x into the form of r cos x plus alpha, all right? So if you remember, the first step I told you, you need to equate both equations. So that means this 5, so that means 5 cos x minus 3 sin x must be equal to r cos x plus what? Alpha. Does that make sense? So I told you the first thing you have to do is to equate both of them. Now the next part is that you need to expand. So remember I said you have to expand the R3 bracket. So that means we need to expand this. So in order to expand that, remember, we need to remember what we talked about in the 4th video in this series. So when I told you when you have cos A plus B, okay, it's the same thing as saying cos A, cos B, minus sin A, sin B, okay? We talked about this earlier, all right, when we're solving. So that means I can apply this now to this. So I can say 5 cos x minus 3 sin x will be equal to r into bracket cos x cos alpha minus sin x sin alpha. Are you seeing? So that means the cos x plus alpha, I can use the cos A plus B trig identity to open the bracket. Then after that, I'll simplify further. So cos x minus 3 sin x will give me r, use r to multiply each of the term, will be r cos x cos alpha minus r sin x sin alpha. So the next thing I told you that we need to now compare each of the terms together, like similar to what we did in partial fraction, what we did coefficient of term method. So what you then have to do now is that we have to compare. So that means cos x, we have cos x here, and we have cos x here. Can you see? So that means for this to be equal to this, so if 5 cos x, okay, must be equal to r cos x cos alpha, okay? So if this must be equal to this, so that means 5 must be equal to r cos alpha. Can you see? So if this must be equal to this, so that means 5 must be equal to r cos alpha. So that means we can now say 5 is equal to r cos alpha. So the same thing as well, we're going to do for sine as well. So this 3 sin x must be equal to all this. So that means we know that 3 sin x must be equal to r sin x sin what? Alpha. So that means if 3 sin x must be equal to r sin x sin alpha, then we can now say if for this 2 to be equal, 3 must be equal to r sin alpha. So that means I can now say, now we know that that will be equal to, this is minus 3, right? Minus 3 sin x. It will become minus 3 will be equal to r sin alpha. Now, the next thing I told you that you have to divide the sine equation by the cosine. This is the sine equation, and this is the cosine equation. So that means we need to divide the sine equation by the cosine. So that is the step 4. So that means for us to divide it now, so it's going to be minus 3 will be equal to r sine alpha divided by the cosine, which is 5 over what? R cos alpha. Okay? So when you do this, you will see now that the R, we cancel this R, then you're now left with what? Sine alpha over what? Cos alpha. Sine over cosine is equal to tan, which is equal to tan what? Alpha. So you can see from here, we can now say tan alpha is equal to minus 3 over what? 5. So if tan alpha is equal to minus 3 over 5, so therefore alpha will be equal to the tan inverse of minus 3 over 5. And that should give you about 30.96 degrees. All right. So we've gotten an alpha now to be 30.96 degrees. Then we can now find our R now. All right. So we can find our R. So remember the R. So we know from this equation, we have two equations here. We have the pink one. Okay. This is the first equation here, the pink one. And also we have the second equation here, which is the blue one. So any of them will give you the answer. So you can select any of them to give you the answer. So I'm going to select the pink one to find for the value of R. Okay. So we know that from the pink one, 5 is equal to R cos alpha, right? So we can say 5 is equal to R cos alpha. All right. So we're looking for R. We divide both sides by what? Cos alpha. So this will cancel that. So therefore R will be equal to 5 over cos alpha. Now, if you look at this already, we already know the value for the alpha already. We know the value for the alpha to be 30.96, okay? So you just put it there. R will be equal to 5 over cos 30.96. So therefore, the R will be equal to, when you put this in your calculator, it should give you 5.83. And that should be the answer for this. Okay? All right. So we know our R to be 5.83, and we know our alpha to be 30.96. So we know our alpha is equal to 30.96. All right. So now we can now rewrite the equation. So remember the original equation we had in the beginning? We had 5 cos x minus 3 sine x is equal to R cos x plus what? Alpha. All right. So we can rewrite this equation now. So we'll go back to write it now. So it's going to be 5 cos x minus 3 sine x is equal to R cos x plus alpha. Okay, that's correct? Yes. So now we can rewrite this equation with our values now. So we can now say 5 cos x minus 3 sine x is equal to R is what? 5.83 cos x is what? X plus the alpha is what? 30.96. And this is the answer for this question. Okay? So, all right. And you can also get this question answer by using the shortcut I showed you in the previous video to look for R. So I want you to do it yourself now. I want you to try. Use the formula that we talked about. R is equal to the square root of a squared plus b squared. And also, I also told you alpha is equal to tan inverse of what? B over a. Okay? So from this question, you can see our a is equal to what? 5. And our b is equal to what? Minus 3. Okay? So if you use it in this formula, you will get exactly what? The same thing. Okay? If you use it, you should get exactly the same thing. So you put it in the formula. So if you want to try it, you can try it. So R will be equal to the square root of 5 squared plus minus 3 squared. And when you get your answer, you notice that the answer is going to be 5.83. The same thing, your alpha will be equal to the tan inverse of the B is minus 3 over what? 5. And you'll see you also get what? Exactly the same thing. And you will notice that when you were solving, at a point in time, you had minus 3 over 5. If you check, yep, here, you can see at a point in time, you had minus 3 over 5. All right? And that will be the answer for that. So let's just pick one more example. And after that, we'll just call it a day. And I'll solve for this video so that we'll not solve so much for this. So let's say we have a particular question where we're asked to find the minimum and maximum values of a particular trigger identity. So let's say the question said find the minimum, or maybe better put, let's say what are the minimum, what are the minimum and maximum values of 3 cos x plus 4 sine what? X, okay? The question is asking us what are the minimum values for, minimum and maximum values for 3 cos x plus 4 sine x. The same thing. So I'm going to use the shortcut here. All right, similar shortcut I use here. I'm going to use the shortcut here to make it very fast. So I can now get my R. So I know my A is equal to 3 and my B is equal to 4. So that means my R is equal to the square root of A squared plus B squared. And that will give me is equal to the square root of 3 squared plus 4 squared. And that will give me the square root of 9 plus 16. That will give me 25. And the square root of 25 is equal to plus or minus what? 5. So therefore, I can say for this question, the maximum and minimum values for this is going to be plus 5 and minus 5. So plus 5 and what? Minus 5 will be the maximum and minimum values that you get for R. All right. And that is that. And that will bring me to the end for this exercise. The next video, I'm going to solve more examples on this. So basically, you just follow the rules. You equate both equations. You expand the bracket based on what I explained to you in the 4th video of this series. When you expand the bracket, you compare like to like. So cos x is here, cos x is here. You compare both of them together. So if this and this are equal, it means that 5 must be equal to 5 cos alpha. Then you divide the sine by the cosine to get tan, and you get the answer. And using the end of the initial equation, you can now get your what? Your R, okay? And here I decided to use the pink one. You can also use the blue one as well. Minus 3 is equal to R sine alpha, and you still get the same answer that I did using the pink was equation. So you can try that, and you get the same thing. Or you can also try using this question here, all right? You can also try using the shortcut, and you should get the same answer as well. Okay. With that, then, I think we'll now solve my example in the next video. So I'm going to see you in the next video. Feel free to drop me a chat or a message if you miss anything or you need some clarification, and I will get back. Or you can put it in the comment section, and I'll get back to you. Thank you very much.